Welcome to Exclusive Learn. Today we are going to learn about the paging technique in operating system. So before moving further into this topic, why we need paging? Because to solve the problem of external fragmentation. So what is paging? Paging is nothing but the memory management scheme that eliminates the need for contiguous allocation of physical memory. This scheme permits the physical address space of a process to be non-contiguous. Moving further into this topic, we'll first learn about the logical address space and the physical address space. So, what is logical address space? Logical address space is the address generated by CPU. And what is physical address space? Physical address space is the actual memory available. So both the logical address space and the physical address space are represented in terms of words or bytes. Suppose if a logical address is 31 bits, so our logical address space will be 2 to the power 31 words. 2 to the power 31 words. Similarly, if physical address is equal to 22 bits, so physical address space is equal to 2 to the power 22 words. So this logical address is also called as a virtual address. And one more important thing, the mapping from the virtual to physical address is done by the memory management unit, which is an hardware device. And this technique is called as a paging technique. So let us start with some of the basic terminology of the paging technique. So suppose there is a physical address space. This is a physical address space and this is divided into fixed size block. This is divided into fixed size block and each block is called as a frames. This is called as a frames. This is nothing but physical address space. And similarly, our logical address space is also divided into fixed size blocks, and these blocks are called as a pages. And one more important thing to notice here, this frames is equal to pages. That is, the frame size is equal to page size. Now, to find the number of frames in a physical address space or a number of pages in a logical address space, we use a particular formula, that is, number of frames is equal to physical address space divided by frame size, and number of pages is equal to logical address space divided by page size. So let us take an example and we'll understand the following terms. Suppose physical address is 12 bits. So what will be the physical address space? Physical address space will be 4K words. Similarly, logical address is 13 bits. Then logical address space will be 8K words. So this is equal to 2 to the power 12 and this is equal to 2 to the power 13. Now let us assume that page size is as we know, page size is equal to frame size. So in this case, we'll assume the page size is equal to 1K. Now as you can see here, 1K words. as you can see here, number of frames is equal to physical address space divided by frame size. So here in this example, physical address space is 4K words. So 4K divided by frame size is 1K words. 4K divided by 1K is 4. That is nothing but 2 to the power 2. Similarly, number of pages is equals to logical address space divided by page size, that is equal to 8K divided by 1K, that is nothing but 8, equal to 2 to the power 3. Now we'll understand the concept of paging in more detail. So this is a logical address space and this is our physical address space. Logical address space is divided into two parts, that is P and D. This P is nothing but page number. Page number is number of bits required to represent the pages stored in a logical address space. Similarly, this D is nothing but page offset, which is used to represent the number of bits to represent a particular word in a page. And physical address space is divided into two parts, F and D. Here F represent the page frame number, that is number of bits required to represent the frames in a physical memory. Similarly, the D represents the frame offset, which is number of bits required to represent a particular word in a frame. Of this diagram, I'll explain you the concept of how we have dividing the logical address space into P and D. P and D is nothing but page number and page offset. That page offset is nothing, the displacement within a particular page. So the total logical address space here is denoted by M and the page offset is denoted by N, and the remaining M minus N denotes the page number. So here in this example, total logical address space is equal to 13-bit, and here we have taken page offset as 10. The remaining will be 13 minus 10, that is 3, is given to number of pages. Similarly, our physical address is also divided into frames and frame offset. Now suppose we want to access a page number 3. So here it will go to page number 3 where we have stored the frame number in which this page is going to be stored. This 2 of base 10, if we'll change this frame into a binary, that will be 10 to the power base 2. Now it will point to the frame and this frame will go to the frame number 2 where our page number 3 details is going to be stored in a physical memory. So that's all about the basic of this paging technique. In the next coming videos, we are going to tell you about the hardware implementation of the page table and other terminology of the paging technique. So thank you, and please subscribe and like our channel Exclusive Learn.